Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, and our guest today is Daniel Quant, Vice President of Strategic Development at MultiTech Systems. MultiTech designs, develops, and manufactures components, devices, and end-to-end solutions for the industrial Internet of Things. In this talk, we discuss the spectrum of enterprise connectivity solutions, from private LTE and RF cellular to LoRaWan. We also explored how campus networks, 5G, and edge computing are driving IoT business model innovation. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Thank you. Dan, thank you for joining us today.
Yeah, pleasure's all mine. Thanks for having us.
So Dan, before we get into the topic of MultiTech systems and then more of a deep dive in communication technology, would love to learn a little bit more about you personally. I think you have a very interesting background. You've worked with a lot of the big players in the area. I mean, you were working with British Telecom back in the 1980s and 90s. You've worked with Fujitsu, with Aeroflex, with Telit. You're now also involved with LoRa. So you've worked with a lot of different organizations from different perspectives here. Can you just take a couple minutes and walk us through how you now ended up with MultiTech Systems as the VP of Strategic Development? What led you, and I mean, you've also jumped around a bit geographically. I think you're from the UK originally. You've worked in the US. You've worked, for a number of years in Germany, and now you're in Minneapolis. So I'm also curious about the road that led you to the Tri-City area.
Well, I didn't see the Midwest in my future, I have to say. And thanks for giving away my age there a little bit. But yeah, I've been working in telecoms, man and boy, you could say. I started with British Telecom when I was about 17, and actually it was a pretty cool job. I used to spend about 6 or 8 weeks working out there with the guys, up poles, down holes, in trunking exchanges, telephone exchanges, visiting customers, drilling, boxes onto the side of their house and wiring in their phones. So, I mean, it was really all parts of the business. And the rest of the time we was at college learning electrical engineering. So it was a real blast at 17, and really probably the best apprenticeship really that you could have in the telecommunications industry. I went on from there into the test and measurement industry, which, is an industry that's always at the bleeding edge of technology. It's a very underlooked part of the industry, but it really is at the cutting edge, as you can imagine. It's all about creating new technology and measuring that and developing wireless and technology and protocol stacks. So like you say, I've worked for a broad set of solution vendors, service providers, and OEMs and manufacturing companies. After moving around in different parts of the world, going where the work takes me, I now find myself in the Midwest, and I'm working for Multitec, and yeah, it's been great. We're servicing so many different types of customers, and it's all about digitization. It's all about better customer engagement that these companies have with their customers. And it's about efficiency and reducing costs and just bringing to life the digital transformation story across most every industry.
Is it true Multitech is 50 years old now? So I guess there's quite a long history of technology development, of telecommunications development behind the company.
Yeah, it's difficult to stay relevant for 50 years in any industry, right? Let alone an industry like ours that literally moves at breakneck speeds. We have to call it G's just to keep up with it. I mean, we take this for granted in our industry, but most industries don't move anywhere near this fast. So you're right, 50 years is quite a testament. And actually, a month ago, Multitech was purchased by a private equity company. So we're actually, after 50 years of family ownership, we're now a bigger entity that actually is delivering a lot more now. not only are we delivering communication products and services, but now actually able to do complete turnkey solutions for companies in typically commercial and consumable markets.
Oh, interesting. So does the PE firm have kind of a portfolio of other companies that you'll be working with closely, or is it more capital injection and allowing you to scale up these new business areas?
Yeah, a little bit of all of that, really. There's definitely other companies in the holdings of the private equity company, North Lane Capital, and we're looking and exploring that at the moment. And yeah, it's a different ownership model, as you can imagine, than a family-owned business. So pretty exciting. It only happened in the last couple of 3 weeks.
Yeah, very interesting. And as VP of Strategic Development, I suppose you're right in the middle of this. That's a lot of new opportunities on the horizon here.
Yeah. Again, a very challenging and interesting job because we get to work with a whole broad array of customers purchasing communication equipment to, as I said before, create their digital transformation story here. And we can do that now at a component level. And we can also do that in a much more bespoke way for companies, bringing together electromechanical design, sensors, authentication technologies, and really bring that together with communications. So it's a strong partnership and a strong merger that's really happening here.
Let's maybe go into a little bit who you're working with. And I guess we could look at this from a few angles. We could look at it from the verticals. We could look at it from the size of the companies. Is it more medium-sized or larger firms? And then also, are you working directly with the end users, or is it more the technology developers that you'd be working with directly?
Well, all of the above, all routes to get to market. But broadly speaking, we have two types of customers. We have OEMs. They could be big companies out there doing EV charging systems, distributed energy resources, kiosks, vending machines. I could be here till Christmas. It is, after all, only 2 weeks away, reeling out different types of markets that we play in. And the OEM model is, a well understood one. They purchase communications equipment from us, could be embedded, could be devices, could be highly programmable with Dockers, containers, and very elaborate architectures and integration to cloud platforms. Or could be more just a USB modem or Ethernet bridge or something of this nature. And then they bring that through into their final product that they sell into the energy markets or transportation, logistics, building management, and so on. So that's one type of customer, and we have many of those customers, hundreds, thousands of those types of customers. Some of them fairly small volume, others big volumes stuff really. And then we have the enterprise. The enterprise is more of a consumer of the technology. They want to be able to connect their video cameras up with guaranteed quality of service and service level agreements, and they're looking to purchase routers and bridges to achieve that. They're looking for products that have management in them so that they can scale fleets of those solutions or connections to their assets. So two types of customers, different type of approach. OEM is much more a developer-driven approach, longer lead times and development times, I meant to say there. So we can really work with them for months, perhaps even years in the case of the medical industry, to help them bring that product to market. The enterprise is more of an IT play, IT buyer. So they purchase equipment, consume it. They're not looking typically to have us in the middle, holding their hands all the way through. They want that product to work and work quickly.
Okay, so you have the technology business that supports OEM and technology development. You have products that you sell to the enterprises. You have services that I suppose you support both with, and then you mentioned turnkey as kind of a new area. What would be a typical turnkey project? Before the pandemic, you've been out of the house. You've been in airports and public areas. You go into a bathroom maybe. You're washing your hands, but you're not touching the taps, the faucets. You're putting soap on your hands,
But again, you're not touching anything to do that. And then you're drying your hands and you're leaving. It's the zero-touch bathroom, right? Well, Multitech specializes in designing that kind of technology that goes into those faucets, that goes into those hand sanitizers and soap dispensers, for example. And it does that in a way in which it's a complete solution for that company. Perhaps if it's taps and faucets, electronics, electromechanical design, sensors, to understand if your hand is going underneath that. That's not their core skill set. Their core skill set is metal and valves and more what you would expect perhaps with water there. Same with sanitizers. Sanitizers is really a chemical supply business for sanitation. You see it in bathrooms, but you also see it in commercial and industrial facilities in massive, great big 55-gallon tanks. And that business is about chemical distribution. So making sure that chemical can only work in those dispensers. As you know, that model has some cross-subsidization to it, a little bit like razor blades. You put the hand sanitizers in for no cost because you know that you're going to get that chemical business. So Multitech develops authentication technology that makes sure that only chemicals and consumables from that company work in those machines. And they do that with design services, full manufacturing capabilities, and we do that with applications on phones that help the service guys see what's going on and identify their problems quicker. So that's an example of being really deep with the customer.
You are very much a technology specialist or an engineering firm, but I imagine that a lot of the solutions that you are developing, especially in this current turnkey or technology development, there's also, from your customer's perspective, often going to be a significant amount of business model innovation around that solution, right? So you're enabling some new functionality, or you're enabling the end user to interact with the system in a new way, and that might modify the business model, might enable new pricing models and so forth. Do you get involved ever in the discussions with your customers around what type of business model might make sense? Or are you typically focused on the engineering problems and not very hands-on on that aspect of the solution?
No, absolutely. We are. As you know, the Internet of Things is all about disruption. It's disruption at a technical level, but also at a commercial level too. So absolutely, we're in the front row of those discussions with our larger accounts and our broad customers. And this is a great reason why we invested so much into private enterprise wireless networks. We could see that as the number of assets increases, we've all heard these forecasts, 50 billion devices connected by, lunchtime tomorrow. And to be able to get that kind of connectivity means that there's a lot of clustered assets inside the HQs and the offices of enterprise companies, right? And once you start getting a lot of assets in a particular campus, facility, or building, then you need to start asking yourself, do I pay a data plan per month, per device? Even if I've got 1 million devices, I bought one more today. So now I've got one more device that's on a plan per month. Or do I start capitalizing this network myself so that I'm not paying per endpoint? I'm paying to scale out the network with the level of performance that I need, where I need it for the applications that I've got. And that journey for Multitech really started with low power wireless access, with LoRa and LoRaWan. And for those listeners who've perhaps never come across LoRa or LoRaWan, it's a low power wireless access technology that communicates at a low bit rate, but it does that over very long distances measured in miles, not in meters, like, say, Bluetooth. So much longer range to a very wide density of endpoints. So think thousands and tens of thousands of endpoints, often in very difficult and awkward to reach places on batteries for years, as in 5-10 years. And so lots of those devices are inside buildings, for example, everything from pest control traps to sensors in bathrooms, to building occupancy management, HVAC systems, and so on and so on. And so really, to answer your question a little bit more directly, we're absolutely at that front row, and that really drives our strategic investment into the technology that we develop.
That's an interesting, and maybe you can update me actually on the status there, because I guess there's kind of a couple different deployment models, right? There's the model, more of the campus network model, where you have some organization that owns a farm or an airport, or could be a government, covering a forest, and they would deploy this for their assets across this environment. And then you have another model where you might have, I suppose, a Sigfox. You might have somebody who's deploying this in public areas, and it's accessible for anybody who wants to have access to the network. Do you see us, one of these models as being more successful or highly adopted right now for LP1?
Yeah, absolutely. And I think you're seeing it already. It's not my opinion. I think the numbers speak for themselves. It's LoRa and LoRaWan, and it's for exactly the reasons that you've highlighted. It has phenomenal agility, and this is what we saw in it about 6 or 7 years ago. It's why we were founding members of the LoRa Alliance, along with Semtech, Orange, and a number of other vendors out there. It's because it's always low bit rate, but you can get really low bit rate, or you can, get up a little bit, maybe some kilobits per second. You get that range. There's no lock-in to the business model. Sigfox is a public service, and everything ultimately routes to a set of servers, perhaps underneath somebody's desk in Toulouse somewhere. But with LoRaWan, you can deploy that privately. You can take one gateway, like a Wi-Fi access point in your house maybe, and you can just turn it on. You've just set up a network. And perhaps it's a couple of 3 miles around your house maybe. And you can deploy that in a campus facility. And you can take that into a public deployment, and you can cover a whole country. There's LoRa deployments in over 120 countries now by over 160 public operators. France is a great example of this. Its 2 biggest cellular service providers or network operators, Bouygues Telecom and Orange, cover over 96% each of France. So I guess there's at least 97% of France is covered by somebody's LoRaWan network. So you really have this tremendous agility in how you want to come at the business model. And you can also dimension uplink and downlink and be a little bit more uplink heavy for sensors, or also be able to control assets like valves and pumps and what have you. So in a nutshell, it's already showing itself as arguably the de facto low power wireless access technology out there.
Okay, so that we can consider to be one, I think, end of the spectrum. So on the extreme, low bandwidth, cost effective. And then what would be the other more common solutions on the connectivity spectrum for IoT devices?
So if you look at enterprises today, most of them are consuming Wi-Fi. No surprise there, well north of, I'm guessing 85%, well north of that. And then you've got cellular now. After 30 years of cellular isn't just about handsets, of course, it's connecting everything, containing container tracking of containers around the world as they come in and out of ports. Probably the best example of how ubiquitous and global cellular is. Bluetooth, a lot of applications out there for Bluetooth, a lot of accessories, but also sensors as well. Short-range sensors, and then you have LoRa, and that's probably the 80% of most of the wireless networks that are really scaling now in the enterprise. And so enterprises are looking to adopt those open standards. They don't want the lock-ins, right? With open standards, you lose the lock-in, and you get a broad set of vendors that generally are very interoperable with each other, and you also are able to create vibrant ecosystems. And cellular is a great example of this. Look at cellular now compared to how it was just 5 or 10 years ago. I mean, it's a huge ecosystem now, and it's really servicing the enterprise. I mean, that's really where the innovation sits. All of this intelligent edge and bringing the core into the on-prem in order to get best latency, resiliency, security, and data performance, that's an enterprise play. And this isn't just Ericsson's and Nokia's and Huawei's anymore. There are so many companies out there, startups like Solona that are really, busting it out and innovating the scene, all the way through to Telrads, JMAs, Motorola's, Ruckus, CommScope, Druid, Athernet. I mean, Athernet won 5 GLOMASS awards last year. That's in the telecoms industry. That's like winning Oscars. And they're doing that by servicing the enterprise with click-to-deploy core networks and infrastructure that's designed for industry and commercial uses. So this market is disaggregating. It's becoming very open based on standards technology. And increasingly, you're going to see more and more enterprises deploying their own private networks, their own private cellular networks, as really wireless foundational coverage for their buildings and their campuses. It's really transformational, Eric, and it's really picking up in pace now, particularly here in North America with the advent of CBRS and spectrum sharing.
So what's the big driver there? Is it the commercial terms of being able to deploy deploy CapEx, and then own that network, but not pay the OpEx for each device? Is it primarily the commercial terms, or is it more the ability to secure that private network or to customize that around specific needs that an airport or a hospital might have? What would you think would be the drivers for adoption of these private LTE networks?
Well, it's definitely the move in the OpEx needle in the CapEx direction for many, for everybody. It's about reliability, security, performance, and control. It's about bringing the network to you. Public networks are very best effort, right? Imagine if something awful happened not too far from where you are now, then the density of that network would get filled up very quickly by first responders and all manner of other entities needing to get access to that spectrum. So it's very much a best effort approach based on time of day, where you are, and so on. Whereas having your own private network, you put that in your refineries, your mines, your office facilities, sports venues, education, for example. You can put these networks into just about any type of vertical market and geography. That then gives you coverage for your assets, where your assets live, with the level of service that your assets require. For some, it is very much a capitalized story. For others, it still remains OpEx. Maybe they bring in an operator that's their throat to choke, that brings in all the vendors and perhaps takes that CapEx and leases it back to them in OpEx. So there's different shades in how the business model works, but I think everybody would agree that it's about reliability, security, performance, and control.
We have this interesting circumstance right now, I think, in the communication industry, where the operators have just kind of finished deploying a lot of 4G base stations and investing, tens of billions of dollars into this. And then this, 4G LTE campus network technology is kind of mature. And then we have 5G now on the scene. I suppose another couple $100 billion of CapEx investment. What is your view on how this is going to evolve? Do you think that there's going to be any type of rapid shift to 5G, or do you really see for the next 5 to 10 years for these 4G networks starting to just continue to mature and become more commonly adopted, because there's probably some economics there that need to be amortized, and then 5G is really a little bit farther off, despite the fact that the technology is here in terms of the actual widespread adoption. How do you see these different generations of technology developing in the coming years?
Well, I guess a way to answer that, Eric, is that you and I, are far more digitally transformed than many of the industries and companies that we rely on in order to just get up in the morning and make a cup of coffee and go to work, right? So the energy industries, utilities, and so on, we're more digitally transformed than they are. And 4G enabled us to essentially become that digitally transformed, where we're socially posting stuff. My Nest is telling me, what the temperature in my house is, and my Philips Hue lighting is, set up the way that I want it, knows when I arrive. So we are more digitally transformed typically than these industries. And it was 4G that helped us get to that point. These commercial and industrial companies, it's 5G that's really going to transform their digital journey here. And that's in part because of the latencies. It's not so much the data rate. I mean, it's nice to have more data. And of course, you get more data, you find ways to use it. But it's really about the latencies. And that harks back to what I was saying about distributing that intelligence to the edge, bringing that into the network. And for sure, the operators are able to offer that. They're looking at network slicing and being able to put more of that infrastructure into the enterprise. But you can't help but see that those operators, their assets are kind of out of whack with where their customers sit, right? 40% of all phone calls and data sessions originate from inside buildings. At least a third of buildings, certainly here in North America, have pretty awful coverage. And the way to solve that is to be able to deploy your own network in those buildings. And you touched on this earlier on, the different types of ways that you can deploy these networks. Well, there's fixed wireless access, transmitting internet and TV services to commercial and residential buildings. So, there's that use case. But within dedicated enterprise networks, it kind of splits out into three different types. You have the pure industrial private network. It's your network. It could be a LoRa network, could be a cellular network, could be Wi-Fi, but it's yours. Only your assets are allowed to use it. Perhaps that data never leaves the building. Perhaps it doesn't leave the oil field or the plant or the facility, in part because a lot of those systems are isolated systems and they're not connected to the internet for safety reasons, for example. Then you have more commercial type dedicated networks. Imagine a hospital, for example. So private network, just like I just described. But now there's a lot of other vendors' equipment in there, like the heating, ventilation system, for example, like expensive bits of machinery that are in that building. So now it's not just your products and your services and your assets and your people. Now it's your partners as well, but you're providing that network. Maybe you charge them for it, maybe you don't. And then there's neutral host networks. And this is where a lot of the excitement now in dedicated cellular networks sits. A neutral host network is, well, imagine this. You go to a stadium to watch a football game or something. And when you're in that stadium, you're getting great service, 5-bar service, very quick, low latencies, everything that you would like. Unbeknown to you, maybe, you're actually on the network in that sports venue, or it could be a big shopping mall, for example, and you're on their network. And the owners of that building own that network, and they make a small amount of money for every voice call and data session that is being securely routed back to your operator. And thereby your operator doesn't have to spend huge amounts of money covering the whole country with 5G in order to provide us these millimeter wave speeds, because now building owners are essentially creating a third market business and revenue stream out of putting those networks up for themselves. And this hasn't been lost on the hyperscalers. The big cloud platforms, for example, are very much driving this, doing rev shares, perhaps with those building owners. So 3 different types of networks there, all often referred to as dedicated enterprise wireless networks.
Interesting. So that's mapping a little bit to the trend that we see in energy of some amount of decentralization of, maybe some factory has solar panels or houses have solar panels and they're able to feed that energy back into the system. Sounds like it's a little bit of a potentially a similar dynamic here. You have this other asset that I don't know how widely deployed this is yet, maybe not so much, but there seems to be a fair amount of excitement around putting these kind of edge computing servers, which are maybe the size of a shipping container or something, at the base of 5G base stations, or I suppose could be 4G campus networks and being able to bring the compute also closer. So when you talk about having access to that latency, that ability to do some degree of machine learning, right there on the edge and be more responsive. Maybe first question is, to what extent are you guys involved in any of these types of solutions? But then I'm curious, what are the types of business models around this? Because you're deploying an asset, and I guess that asset could be owned by a hospital or a mine or some company, but it could also be a public asset. So if you're thinking about transportation networks, then that would be a different system in terms of how the business model would have to operate.
Let's use an example where perhaps Multitech took really a first to market innovation and leadership in. So LoRa and LoRaWan for that low bitrate connectivity, massive IoT. That was a model that was much like how cellular was a few years ago. You have devices, they connect to base stations. Base stations are called gateways in this case. And then the gateways are connected to a core network. The core network's called a network server. And it's a classic telco model. The gateways are pretty dumb. They're scattered across the country, say like the example I gave with France. And then the core network is inside the middle of a telco building. It's probably a brick building with no windows. You probably walked past it for the last 5 years, didn't even notice it was there. And that's where the core is, right? Well, what Multitech did is we took that core network and we put it actually inside the gateway. And that gave phenomenal agility. It meant that the enterprises who don't have that telco skill set, they don't think about core networks and RAN, radio access networks. They don't think like that. They think like Wi-Fi. I buy a Wi-Fi access point, I plug it in, I stick in Ethernet one end, and then I've got this magic wireless signal that can connect all my devices with greater agility and mobility than I had before. And so that's kind of where we started with LoRa about 6 years ago. And it really took off. I mean, I knew it was going to be popular, but I guess I didn't realize quite how popular and how much pent-up demand that there was for distributed edge intelligence and a more CapEx-based model to connect in a large density of assets in a particular location. And here we are now in 2020, and this is the whole rage of cellular, right? It's all about disaggregation and open vRAN, virtualizing the core network and the RAN into an on-prem deployment or sat at the base station tower for better latencies for applications like AR and VR. I don't know if you've ever put on an AR or VR headset, but if there's much of a time delay, it makes you feel queasy and a bit sickly, to be honest. And so that's a great example where latency really counts. And the speed of light is the speed of light, whether it's going through cables or not, right? So bring stuff closer and that round trip delay is shorter. So we started that very much with LoRa, and you start to see now a broad ecosystem of players doing much the same in a far bigger cellular market.
Are we missing anything in here? I think we've covered probably the main. I guess we haven't touched too much on Bluetooth. I mean, there's things like ultra wideband. There's some other solutions that maybe for logistics centers might have particular uses. Any other technology domains here that we haven't touched on yet that you think are also quite important?
I think that the big game changer that came out of 2020, at least in my life anyway, was Citizen Broadband Radio System. I mean, this is huge. It's a paradigm shift. Up until now, if you wanted to go wireless with any kind of business model, you had to figure out how you was going to get access to spectrum. And spectrum, is a highly sought after commodity. This isn't like the multiverse where we can create lots of different universes out there. This is a one-off entity in a location. Once you've sold, 900 meg block of spectrum in Shanghai or in Seattle or Minneapolis. Once you've sold that, you've sold it. That's it, right? And so that's why we see so much congestion in the sub-gig band, because of course we started off with low frequencies, and as we got more adapted digital signaling processing techniques, we were able to move up and up and up to millimeter wave band, where we can get hundreds of megahertz of spectrum, almost like being at the top of a mountain, having, all of that land to ourselves. And so using that land analogy, CBRS is a shared spectrum concept. So instead of, you get your cake and eat it, essentially. You get all of the clean exclusivity, high availability of access to spectrum that you get when you pay billions of dollars to buy it, like's happening in the US now with the C-band auctions that's been going on all week and is raising huge numbers of revenue for the US government. So you can buy spectrum and get all the beauty of being the only one who uses it. Or you can use unlicensed spectrum like Wi-Fi. And it's a bit like the wild, wild west. You look at how many Wi-Fi access points are around you, and sometimes you're shocked. There's like 20, 30 of them around you. But as long as, you stick yours up and you've got a signal, it's all good. I mean, when was the last time anybody turned on a Wi-Fi access point and went next door to knock on the neighbor door and say, look, I'm sorry, but I've turned on a Wi-Fi access point. There might be some noise pollution. I'll do my best to be on a different channel to you. I mean, it's ridiculous to even discuss, right? I mean, nobody does that. And so CBRS, cake and eat it, right? You get managed spectrum with high availability and exclusivity of spectrum, but you get to deploy it all over North America without having to knock on the guy next door's house and apologize for stealing his spectrum. So this is a game changer. And we've seen a number of private enterprises now deploying those networks. Oil and gas is a great example. They spend millions of dollars on POW auctions to be able to buy their way up this spectrum sharing a little bit more. And we've been, this, if anything, showed the digital divide across this nation. It's been the pandemic. Kids working from home rather than going to school because of COVID. That's really shown what kids have fiber, 100 meg connectivity, can sit on Zoom all day long and do their learning versus kids who can't. And so we've seen a big uptick in school districts here in the United States deploying their own networks to connect kids who couldn't get connected before. So it's a real game changer, the CBRS. And you're going to see, you're already seeing shared spectrum in other countries like the UK, France, Germany, and so on. And you're going to see a lot more of this. And it really comes hand in hand with these enterprise industrial wireless deployments.
Is this primarily a policy change by the governments, or is it a new technology that's just been rolled out recently?
Well, it's not a technology, right? It's spectrum. It's 3.55 to 3.7 gigahertz. So that's the spectrum here in every United States county, including outer territories like Guam and what have you. So it's a US thing right now. But anybody who's been following 5G knows how hot the mid-band is. Every country in the world is deploying 5G into that 3 gig, 4 gig mid-band area. And so it's become really political, as everything seems to get these days. So Trump and his administration, they've really pushed hard. That's why they're doing the C-band auction today. C-band is 3.7 to I think 4.1 gigs, so it's right above CBRS. And the FCC has already signaled now that it's going to drop down to 3.45 to 3.55, so the other side of CBRS, and try to open that spectrum sharing up to a broader spectrum. The UK is doing shared networks between 3.8 and 4.2, Germany in 3.7 to 3.8. You see this all across the midband. And it's because as I said earlier on, the low frequencies have all been taken. That's where our radio, our TV, our initial cell phone services, government stuff, it's all in those lower bands. So you kind of have to move up a little bit. And that's where 5G is finding the kind of bandwidth that it needs.
Yeah, no, I was just curious about the CBRS. Why it sounds like this is quite impactful, but just curious why this wasn't rolled out 5 years ago, whether there was any needed technology support. It was just...
Yeah, because there was incumbents in it, and the incumbents weren't, the guy down the road. That they were government agencies like the Department of Defense, and these kind of entities don't like to give up exclusive access to spectrum.
Okay.
So it did require a bit of a push from government to make it happen. And I sort of conclude on this CBRS with this, right? even though that C-band spectrum that's going on right now, auction 107 by the FCC, even though it's already netted billions of dollars, and I'm sure will go above $10 billion by the time it plays out, that's like finding change down the side of the sofa, believe it or not, than the amount of money that is generated by enterprises digitizing their products and services and their customer experience. It's what makes us, retains our global economic superiority here in the US, and I'm sure in other nations. Australia measured that their 4G network added $2,000 to their GDP per capita. And it's how much GDP per capita has been added over the last 10 years with the reliance on Wi-Fi across every enterprise, right? So when you start looking at thousands of dollars of GDP per capita being added, this is really, it makes $10 billion look like change that fell down the sofa. It's all about economic superiority and productivity, and that's what makes it very political.
Yeah, I was just reading a rather hopeful analysis. I think it was in The Economist, but looking at productivity, and there's been slow productivity growth in a lot of developed nations since around 2008. And one conclusion could be that we're in a tough spot, and we're for whatever reason not, our innovations are not paying out. But their conclusion, a little bit more hopefully, was that productivity takes time. First, you invest, and that invest costs money, and it doesn't immediately result in a productivity improvement. And that might take 5 to 10 years. So you see a bit of a dip, but then that investment, just like computers took time before they really started to have an impact after the investment we're making, we might start to see that in the coming years. This, maybe we're already starting to see it a little bit in the COVID environment, the fact that we're able to really start implementing very useful applications on infrastructure that was already there, and we just weren't maybe optimizing it. So this tragedy that we're living through right now might have a little bit of a silver lining in terms of accelerating our ability to really generate a lot more value out of this infrastructure that we've been putting in by necessity. But I think processes that have been put in place are going to be sticky, and we'll continue to use them, after COVID is solved and we move on. Is there anything else, Dan, that we should touch on here? Anything that we haven't covered yet?
No, I think we covered quite a bit here today. We covered how enterprises are capitalizing more of their wireless networks. They've been doing it with Wi-Fi. They've perhaps outgrown some of the capabilities of Wi-Fi. And so now I think many enterprises out there are looking to converge their wireless networks with a cellular umbrella foundational coverage in their campuses and buildings. And it's not just about cellular. It's not one bullet that can, the one ring that reigns supreme. It's about using that to provide agility. So in sports stadiums, they want to be outside the stadium on game day, welcoming you in, barcoding your tickets to validate that you've got a ticket and ushering you in. Of course, the moment they put their foot outside of their stadium, even with 1,000 Wi-Fi access points in that stadium, as many stadiums do, they lose the signal, right? So by having cellular foundational coverage, they can move Wi-Fi access points out into that area and thereby close to the guys with the barcode readers, for example. So you start to see that cellular becomes that more business mission critical foundational coverage. Wi-Fi becomes more worker productivity type tools using our laptops, which of course is great for Wi-Fi. And LoRa is a great example of a wireless technology that, when coupled with cellular connectivity, provides massive IoT connectivity. And it's not just the RF technologies being blended together to offer the best KPIs for whatever application is trying to be achieved. It's also about integrating that into these on-prem networks so that you get quality of service and service level agreements. And it's about also converging on the data platforms that you're using, like Azure, Amazon, Ignition, OSIsoft, or whomever. And even at the application layer, trying to disaggregate devices from applications to prevent those lock-ins with sub-pop technologies like MQTT and Spark Plug B. So you see these enterprises are really converging their digitization strategy from RF all the way up to their application layer. And 5G is very much going to make that happen. And shared spectrum is a way to be able to do that at the cost points that massive IoT deployments will require.
All right. Well, Dan, I, for one, will welcome the golden age of IoT. I think we're moving into an environment where it will be much easier to do things that are interesting and useful. And the technical solutions that we've been working on in the past 10 years will now start to bear fruit. So
time for a name change, Eric. It used to be telemetry, then it was M2M, now it's IoT. It's about time for a name change again. And you know what happens every time it changes its name? It gets way more complicated.
Well, I hope not, because we banked that name into our company name, IoT ONE. So hope we can keep using that for a while longer.
Yeah, I think you're good.
Okay, thank you, Dan. I appreciate your time today.
Pleasure's all mine. Thanks for having us.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.